Welcome to this deep dive into SQL internals, the video which gives you end-to-end understanding on how data stored in SQL tables. Have you ever wondered what happens behind the scenes when you run a query? How does SQL store, retrieve, and optimize your data for performance? In this video, we will answer these questions and more. In this session, we will break down the low-level details of SQL storage architecture. We are not just talking about tables and rows, we are going beyond that into data pages, extents, B-trees, and indexed B-trees, etc. The core structure that determine how efficiently your queries run. Understanding how SQL stores data is crucial, whether you are a developer, database administrator, or performance engineer. This knowledge will give you the foundation to optimize queries, design efficient indexing strategies, and troubleshoot performance bottlenecks. By the end of this video, you will have a clear understanding of how SQL physically stores data on disk and in memory, the role of data pages, extents, and B-trees in organizing and accessing data, how indexing structure like cluster index impact the performance. So if you are ready to level up your SQL skills and master high-performance database operations, let's get started. Let's try to understand how data stored in SQL table. There are two ways of thinking of it. The number way is the logical or a visual way to think of it, wherein we call it as the table. And the table has got two things. The first is a field and second is a record. So if you see this snapshot, this table, TBL employee, has got four fields: employee ID, employee name, employee email, and salary. And if you see, 1001 is employee ID of Dino Jason, and who is having this email ID and salary. So this is a record of Dino Jason. This is the first way of thinking data stored in the table in the form of rows and columns. Other way to think data stored physically on the devices. Then there is a concept called data pages. Then we are thinking of something called extent. Then we have a tree structure, we have B tree, we have cluster index structure, stuff like those. We are going to explore these. I am in SQL Server Management Studio and I'm going to create a table for you, the TBL employee. This table has got four fields: employee ID of integer type, and please notice here is that this field is of primary key type as well. This is a constraint applied on employee ID. We have employee name, a varchar of 200, and employee address, a varchar of 200, department name, a varchar of 200. I have intentionally kept the sizes bigger, so please ignore that. There could be some purpose of this. Make sense? So the concept of primary key is if you are introducing primary key constraint on any field, so it doesn't allow duplicate data to be inserted for that particular field. In this case, employee ID cannot be duplicated. In other way, we can think of there won't be two employees or two records in the table who will have same employee ID. Make sense? There is one more thing that comes along with primary key is in SQL Server, when you create a primary key, there is something called clustered index that gets created automatically. So we are expecting when we create this table, then there would be an index, clustered index, that will get created on this primary key field, that is employee ID. Let's go and create this table. Selecting this setup script and hitting the execute button, this table gets created. Let's go and insert the records in this table. Let's go and insert it, hitting this all insert statement. 14 rows gets inserted. Let's visualize the data. Select all from TBL employee, and we see that this is the data of the employee. This is employee ID, employee name, employee address, and department name. Make sense? So we have seen in this example that data can be thought of in the form of table. So you see, this is the data that we recently created in SQL Server Management Studio, and this is These are all columns or fields. So employee ID, employee name, employee address, and department name. And these are all records. This is record of Maya Gill. This is record of Suresh Khanna. This is record of Leena Roy. This is record of Lekha Ray. And this way, this all horizontal line is called rows or records. Make sense? So this is the first way of thinking how data is stored logically or visually in SQL Server in the form of tables. Thinking about how data gets stored physically. So physically, the data is stored in something called data pages. So data pages is called as the basic unit or fundamental unit of data storage. Okay. And how does it look like? It is 8 KB kilobytes in size. So each data page will have of size 8 KB. So in order to store the details in record, it saves a series of 8 KB of data pages. Let's say if your data which you are storing in the table will be more than 8 KB in size. So it extends its data to another page and so on it goes. And then it creates the series of 8 KB of data pages. And all these data pages will be linked together by some mechanism. We will explore those. Make sense? So once you are combining 8 such data pages together, then it becomes an extent. So the extent is nothing but it's a collection of 8 data pages. The extent can be uniform extent or it can be mixed extent. If you say uniform extent, that means all these 8 pages will belong to the same table or same index. Let's say you have a table which contains some data. So if it is for specific table, then all the 8 pages, then it will be called as uniform extent. But if there are pages from multiple objects, like multiple tables, then it becomes a mixed extent. So this is the basic difference between uniform extent and mixed extent. If you want to differentiate between data page and extent, data page is of size 8 KB, whereas extent is of size 64 KB. 8 into 8 becomes 64. The data page stores table rows excluding LOB data, but this is the extent stores pages instead of data. So there is a collection of 8 pages becomes one extent. The usage is the basic unit of storage, but it has multiple pages. So hope the difference between a data page and the extent goes clear here. Let's go and dive into and go deeper into the data page concept, the structure of data. Any data page which you think is containing 4 things. The number is the page header, which is of 96 bytes, and the page header stores the metadata, the data about data, like page ID, like object ID, like how much free space is, etc. And if you're thinking about second thing is data rows, then third is free space, and then the fourth is row offset table. So if you're talking about data rows is actual data that is stored in data. Let's go and see these things in action. I'm going to create a demo in which I'm going to show you how data pages are allocated in SQL Server Management Studio. I am in SQL Server Management Studio, and just to understand the data pages internally, let's go and create a table. The table is a test table. This table has got 2 fields, field 1 and field 2, and both are having the sizes like field 1 is 7,500 and 2,000. Combining these two becomes 9,500. So there is an intention to write the sizes or make the sizes like this. So what I'm going to do is I'm going to create this table and I'm going to insert a record out there. So let's create this table. This table gets created, and then let's go to insert one record. So I am inserting some sort of content into this table, right? So the record has been inserted. Now we have a function called data length, which can give you the length or the byte size of the field. So let's try to find out how much byte that each field, I mean there are 2 fields, so each field contains. So you see that the first field contains 6127 byte and the second field contains 198. Combining these two becomes 8045, right? So what I'm trying to make you understand is I have created one record and the record size is within the range of 8 KB. If it is within the range of 8 KB, there would be a single page creation and the database will be visible. One leaf node will be visible. So we have already seen these in previous snaps, but let's try to see these things in action. We have a command called dbccind and which requires the database name and the table name, and -1 is a parameter. So let's go and execute this. So once we execute this, we see that this page, we can see the one page here. This is one page here, which has a page type 1. So this page is having page types. One is the data page, which contains the actual data. Page type 10 is an IAM page, which is called index allocation page, which holds the information about extents, if any. And if page type is 2, this is index page. And likewise, if page type 3, that is text page. So here, only one data page got created because the size was considerable and it was within the size of one data page. Make sense? Let's go and deep dive into this data page as well. Okay, so data page has got this page ID. I am copying this and let's go, and we have a command called dbcc page, and this requires the page ID here. Okay, so let's go and try to see the details of this. So see that it shows that page, and if you are coming here, you see the internals of that page. So we say all this here, and if you come down and scroll down, this is all the data that we wrote into the page on different locations. And scrolling down further, you see all the details of the page. So this is what you see right now is the internals of a data page. Make sense? So you can actually visualize the data page out here. Now let's go and increase the length of the size of the data which we are going to insert into this table and see if there is increase in the number of pages creation. So I'm going to add couple of characters to this, and let's go and recreate this table. So let's go and recreate this table. Table gets created, and let's go and insert this. So we have inserted this, and now let's go and find the length and also the page details. So this time the length has increased. It is going beyond that limit of one data page, and hence we can see multiple page creations here. I'm not going into the detail, each and every detail of this output, but yes, you can see that the moment your size of the bytes in one record increases, and as per our understanding, number of pages will get increased accordingly. Make sense? So this is how we can understand the data pages internally. So we have seen that when we created a primary key on this table, a particular index gets created that is called clustered index, and this is by design implicitly. So you can actually visualize the cluster index or any kind of index from the table by using this command sp help index and the table name. And you see here is this shows me the index name, and this is the kind of index is cluster index, unique primary key located on primary, and on which field this index has been created, employee ID. So if you say if any index gets created, so what happens? This tries to store the data in a sorted way on that based on that particular field. So we are assuming that since the index has been created on employee ID, internally the data will be stored in sorted way. And why do you store, or why do you need sorted data? It's a very simple understanding here. If your data is sorted or arranged in a particular sequence, it is very easy for you to find if something you want to find it. So we are going to see the same thing in next couple of slides. So default cluster index is created, and you see that data when it is stored, it maintains a kind of tree. So this tree has got 3 sections. The number 1 is a data pages, data page or leaf nodes wherein actually data is getting stored, and then the first is the root node where the root starts, and this also contains the reference to the other nodes, and these are all called these intermediate level nodes, right? So in our case, based on the size of the row, let's say one page may contain 200 rows. Okay, if let's say our page contains 200 rows, it depends upon the size of data in one row, but let's assume hypothetically, then the leaf nodes will contain the rows like the one below. What will it contain? 1 to 100 in the first leaf node, 201 to 400 in the second leaf node, because we know that the data gets stored in the leaf node and the others are the index nodes in the tree. And likewise, you see that all the data that gets stored like this. Make sense? So this is a hypothetical example. We are thinking that one data page can contain 200 rows. So 1 to 200 in the first data page, 201 to 400 in the second data page, and like that. Now, if it is index column, what happens? Each index row in the tree contains a key value pair. And how this? Since you have created the index, you know that cluster index has already been created, and that is on employee ID. So employee ID will be the key, and the pointer to the next intermediate level page will be a value. So you can think of a scenario. This is a key and then value. So each key and value pair will be stored. Because you have created a clustered index on employee ID, then this will be maintained. If you had no index, so this would not have maintained like that. The tree-like structure has a series of key value pairs, and which helps the DB database engine to find the data correctly. So we understand that employee ID and the value, employee ID 2 and the value, like that, everything is getting created. So it will be easier for you to get the data. Now you are going to write a SQL statement. The SQL statement is select a star from employee where employee ID is 150. This looks very simple SQL statement, but if you have not introduced indices, or if you don't know how the data has been stored internally, you actually don't know how it gets executed. So let's go and deep dive into it, how SQL Server Database Engine works for it and tries to find the data. So we know that there is a structure tree. So this tree structure has it's a B tree. And if you know the concept of B tree, the left side are the smaller ones, the right side are the greater ones. So here, this particular index will have 100 to 400. And out of this 100 to 400, this will 1 to 400, sorry. And out of this 1 to 400, 1 to 200 will be to the left data leaf node, and 201 to 400 in the right data leaf node, right? And likewise, in this particular has 401 to 800. So 401 to 600, because each page may contain 200 records. That is a hypothetical scenario. And this way, 601 to 800. And if you are going to the right side, it contains 101 to 1200 records. So 801 to 1000 is in the left leaf node, and 1001 to 1200 in the right leaf node. So what is our question? Our question is where employee ID equals to 150. So the engine will try to find out. It's 150. So obviously it will not come to the right side. So it will definitely come to left side. So here it is 1 to 400. So it will jump here first. So it jumps here. It says that coming here. Now from here also it has two way. What is the requirement? Where employee ID is 150. So from here, this is 1 to 200. So 1 to 200 falls in 150. So it will come here. It will not come here. Make sense? So now see, it comes here and then it finds the data. So you see, whatever bigger your data set is, it can find in 3 iterations maybe, right? And if you had no index on this, probably this tree could not have been used this efficiently, and you could not have got your data so instantly. Make sense? So this is how data gets stored internally, and when you request a select command, it gets you back the data you requested in no time. Make sense? So I hope the concept of how data stored in SQL internally is pretty much clear to you. I'm sure that you are going to utilize these concepts in future for your performance tuning activities in SQL Server on an advanced level. If you found this video helpful, don't forget to hit that like button and subscribe for more high quality technical content. Also, hit that bell icon so that you will get the future notification. Drop your question in comments and I will be happy to answer them. See you in the next one. Bye bye.